Okay, my next example here is not using the sine law. Notice that I have an angle down here, but I do not know the side across from it. Notice that I have these two sides, but I also don't know the angles that are across from those two sides. So I'm going to have to use the cosine law, which is this. C squared is equal to a squared plus b squared minus 2ab cos c. It's pretty long, but notice that it looks very similar to Pythagorean theorem, and that's kind of what it's related to. So let's see here. Notice that c is a side, and cos c, this big C, is the angle. So if you can kind of keep that in mind, then that's what I'm doing. I'm going to label this side C and this one little c. So I'm looking for x, and that's the angle that I have. The other two sides, A and B, don't really matter other than the fact that you need to know that they're not related to C in any way. They're not part of C. So let's fill in my missing information. This is the side C, which I don't know. So we're going to call that x, and that's x squared equals. Does it matter what I call A or B? Not really. So let's call 13a squared plus 15 squared minus 2 times 13 times 15 times the cos of my angle, which is 43. Notice the setup too. I have two side lengths and an angle in between those two side lengths. That's a really big hint to use the cosine law. So let's work this out. Notice that everything on the right side I can work out on my calculator, and the left side is what I'm trying to find. Let's have this. X squared is equal to. First thing I'm going to do is I'm going to do my cos 43. There's kind of tricks that you can use for calculators that don't have good order of operations. So cos 43 times 15 times 13, and then times 2. And I think I'll leave it for there. I got my 13 squared plus my 15 squared minus, just because I have to subtract off 285.23. And always round to about 2 decimal places. It's a good idea to be very accurate. Next thing I'm going to do is 13 squared, 169. We all know that 15 squared is 225, and that's going to subtract off my 285.23. Next step is just some arithmetic on my calculator. So I add on my 225, and I subtract off my 285.23, which leaves me with 108.77. And that's equal to x squared. How do I solve for x? Opposite of squaring, square root. Sorry, square root both sides. So I have 108.77. I take the square root, and I'm left with 10.43. Great. So we've worked through the cosine law. This is a basic example where you're solving for the side that's right across from the angle that you're looking for. Now, here we have a final example. Of course, I'm not giving you the angle this time, so we're going to have to solve for the angle. But again, keep in mind that my C and my C, here's my big C and my little c. And again, A and B don't really matter which order you put A or which one you put B. So here, I'm given C this time. I have 22 squared. That's the side right over here. 22 squared is equal to 27 squared, or 35. It doesn't matter which one you put first. Plus 35 squared minus 2 times 27 times 35 times the cos of my angle, which I don't know, so we're going to call that cos theta. Now, it's a good idea to think of this cos theta as just a variable, because we don't know what it is. You could even call it like a or something, but I'm just going to put it in brackets just so you know it's on its own. Now, I got to work through this stuff, right? So 22 squared, let's do that one more time. 22 squared, 484, which is equal to 27 squared, 729, plus 35 squared, which is 1225, minus, and then I have all this stuff here, the 2 times the 27 times my 35, which is 1890, and that's connected by multiplication. make the mistake of having this adding or subtracting. It's being multiplied by my cos theta. Just be aware of that. Because a lot of people say, oh, I can just add this to both sides or subtract this to both sides. No, you can't do that because it's multiplication. What I can do, though, is I can subtract off my 729, and I can subtract off my 1225, because those are just being added and added to that side. So I subtract those both from this side here. Subtract off my 729 and subtract off my 1225. Yes, you're going to get a negative answer. So what do I have here? 484 minus 729 minus 1225. So I'm left with negative 1470. Notice I have no decimals, which is nice. And this is equal to negative 1890 times the cos of theta. Again, you don't have to put these brackets. I'm just showing them to show that it's a multiplication. Because I want you to know, how do I get rid of the negative 1890? Do I add it? Subtract it? No. The opposite of multiplication is division. So I have to divide by negative 1890 on both sides. So I have negative 1470 divided by 1890, which is negative, which is equal to 0.7777. Now, I'm going to round on paper, but remember, I'm not going to round on my calculator. I'm going to leave it. And that's equal to cos theta. How do I solve for just theta? Remember, I take cos to the negative 1 of both sides, or the inverse of cos of both sides. And it's really easy because when I have that answer on my calculator, I can just hit inverse cos, because that's cos to the negative 1, and it gets me 38.94 degrees. So 38.94 degrees is equal to theta. So it's not too bad. It looks like a bit of work, but it's not too bad at all. You just have to remember to subtract these two values, and then remember to divide by that value that's in front of cos theta, and you should be fine. So that ends off working with the sine law and the cos law.